Hey, Simon, thanks for traveling in today. I appreciate you traveling all this way to visit with me.
It's a pleasure to be here, to have this opportunity to discuss with you for what we can do to address the challenges in our industry.
Excellent.
Our industry has been always challenged with the question how we can do more, achieve more at a lower cost.
Yeah, this is true. Always is, Simon, always is.
Yes, so I think for the optical networking industry, innovations has been delivered by many vendors to push more bandwidth into the network by doing the optical electrical conversion, transmitter receivers on the transceiver side to increase the speed from lower speed now to 1G, 10G, 100G, all the way to 400G now. And also on the transmission side, for the fiber technology evolution, you can also see a lot of innovations there from the beginning with all different type of fiber improvement to reduce the dispersion, to make the banding more insensitive, to meet the requirement to put more and more bandwidth in the transmission line. Now, the other challenge that we see that has not been addressed well enough is how to make the connection, the optical connectivity part, to squeeze more and more, to do more but cost less.
Yeah, very true. Like you said, we've spent a lot of innovation on the fiber itself. I mean, it's still basic G.652 glass, right? But we've changed the dispersion window. We've changed a number of. We increased it, then we decreased it, then we put it to medium dispersion. Lots of different ways to try and increase the fiber capacity. And even if you go to a conference today, there's lots of folks and saying maybe multi-mode kind of fiber or few mode field fibers or multi-core fibers or things of that nature. Again, trying to improve that piece of it. But as you say, you go over to the other side of the show and it's still a patch panel. You know, there's a lot of them that look identical. And I think you guys have done a great job of trying to pull that forward into how do I make it more usable and more compact, because the space constraint, you know, on electronics keeps getting lower. Right, they're more and more dense every time. Every generation of equipment is more dense.
On the electronic side. Yes.
Exactly, exactly. And the backplane speeds are higher. We're getting more and more capacity out of a shelf, but we still have connectors.
That's right.
You know, we still have connectors on the end of it, and that's the part that hasn't changed a lot over the years.
Yeah, not that much until we try to address that issue to do more on the patch panel side, and to have less space, less CapEx, as well as less OpEx.
Yeah, but as you know, things evolve slowly in that area. I mean, Sam Charlie connectors have been around for a decade or more longer, right? And it was always viewed as anything smaller could not be handled, where we've recently made the change over to LC connectors because of the half the density, or half the size and double the density. And this is really key to a facility because, again, we're getting more and more capacity out of the shelf. But if the racks of the patch panel still take up half the floor space, then what did you really gain? You know, we need to make that space more usable. And part of the goal was a large operations pushback in how do you go from an SC connector to an LC connector. We even tried the MU connectors at one time because it was even smaller, but it became unmanageable as soon as you had too many of those on a card or in the equipment itself. Now on a card, we're also doing better with the MPO connectors, you know, so that we can, again, improve that density.
That's the key for the challenges we try to address here for optical connectivity. And like what you said, from a single fiber to multiple fiber, and also try to shrink the footprint of a connector while maintaining the easy access. To address that, until it is fully automated, a human's factor is still a big factor over there. As you mentioned about the MU, it's a nice connector. From a footprint size, it's smaller, but it's a challenge to handle it until we develop this platform to address this challenge by expanding
very unique.
this distance in between all those connectors while you operate on them, but then you can push them back together to store it when it's not being operated. Right. So this platform we developed, we call the platform with enhanced access, PEA, for compact optical connector, COC.
Mm-hmm. Yeah, and as you say, because it's not just the initial installation as well, it's the maintenance later. You know, you can always argue that the guy installing the equipment is only doing it once, and perhaps he could use a tool, or perhaps he is specialized in that area. He's had special training, and he's done it many, many times. The argument can be made that is acceptable. But then you come to maintenance. Yes. And maintenance occurs at the worst possible times, usually in the middle of the night with somebody who's really in a hurry because he's got a lot of things to do, and he's trying to find the appropriate connector that needs to be replaced and to do it right, and also to get it back. And in many cases that's on a card where there are 20, 30, 40 connectors, or it's in the panel itself where he's trying to find number 7, remove it, and move it to slot 14 and replace it without making any mistakes. Yes. And again, it's somebody who's just as skilled perhaps, but works on all different kinds of equipment types and connectors, and he's usually in not ideal conditions when he's got to do that work.
These kind of optical connection may show up anywhere, anytime, and it's not necessarily in the conventional case that it is on a full rack in the central office. Right. It can be anywhere, and anywhere you still need the compactness. You still need the high density. You still need to have easy access. So the Peacock platform we have developed also try to address that concern.
Yeah, exactly. And you know how a telecom network is that way, right? It's very distributed. Mm-hmm. We've got sites all over the place. And many times they don't require a full rack of equipment or connectivity by any means, but there is connectivity requirements in every site. That's a given. There's always going to be a patch panel. We tried Direct Connect for a while and it didn't work. It works good again from that initial installation when you've engineered it, but it never fails. Things evolve, day 2, maintenance, whatever must occur, new ads come in later. Direct Connect just doesn't scale well. You need the exact size patch cord and everything else. It still makes sense to have a centralized patch panel location. It's just that you don't need a full rack. I only need, a couple of hundred connectors, and today that can be put into a relatively small space. And also we can have MPO connectors going to the equipment. If we can get access to all of that in one panel with multiple, MPOs on the back and single connectors up front so that you can get the granularity that's necessary, then obviously that's the best choice going forward.
That's interesting. This talks about another key part of the challenge is the flexibility. And for the flexibility needed in the network, whether it's in the central office for a full rack, or it's in a distributed format with a chassis you need our modularized design can offer that versatility wherever you need to do in a specific environment to fit that environment's requirement. And also for the easy access, it's not only necessarily for the fingers, the fat fingers, so to speak, quote unquote, to address a smaller, to deal with a smaller connector, but also to move around back and forth on the 2 aisles of the racks. Our design, of course, can be front and back access, but we are moving towards more a front access only operation to make this much easier for the technician to deal with that all in front of him while standing there.
Ah, very good. Much like we've asked we've been doing equipment for quite some time, decades actually, that would fit back to back, so that you can stack it against a wall, or that you can maximize your space in a shelter, as an example, a small cell site shelter as ones we use all the time. Back-to-back equipment offers a lot of advantages, and if you can access what would be the equipment side from the front and the user side or the client side from the front as well, then you could stack those back-to-back and double your density on the lineup also. Very interesting.
Yeah, so the versatility of the Peacock platform, actually that was one of the original design concept. That concept or technology we call Peacock can tailor to different environment, different application, and the platform can also house various optical components on the back to actually integrate a lot of other functions to be on the patch panel platform and to meet the requirement of doing more but cost less concept.
Cost less, and also, as you say, the functionality, because many times there's splitters or monitors or perhaps breakout panels. We have lots of breakout panels today because, again, on the card, we've got a 10x or 100x improvement in the capacity, so we can't fit that many connectors, but we take it to a breakout panel. I think we will continue to see this trend. I mean, I eventually would imagine pluggables going away and connections going right onto the board, or certainly multi-connector or fiber connectors, so that we can increase that, take advantage of all the capacity on the shelf, but yet be able to break it out onto a panel so that you can get to the individual component level or individual client level circuits.
Yes, the Peacock platform itself, as I mentioned, can accommodate both the panel in a full rack or chassis perspective, but also that concept, as a matter of fact, can be further developed, which we don't have a product yet, but can be further developed to be on board. For a line card, for instance, if there is too much of the optical interface on the front for the faceplate, it can be also used for that.
Moving it from the patch panel onto the faceplate. That's a very interesting idea. Because again, this is what's limiting us today is faceplate real estate just isn't sufficient to get all of those pluggables or all those connections on it, and that's why we've looked at MPOs. Now, of course, the issue with MPOs is then they're harder to clean, they're harder to maintain, scope, and keep consistent over a large period of time. So that would be very interesting.
Yeah, and also speaking of those MPOs, as you said earlier, it can be breakout too. So back to that concept, from MPOs to different configuration of MPOs, there is this fiber shuffle thing. And for fiber shuffle, both sides are just connectors. And then the Peacock platform can also accommodate that and to shuffle the fiber, quote unquote, on the platform with front, back, or both front access.
Yeah, once again, building more things into the same real estate.
That's right. And try to address the challenge of doing more and cost less.
That's a very good objective.
Yeah, this has been a constant challenge for our industry, and for EO OE conversion, it was part of onboard and came out of the board to be a separate optical module, and now it's going back to board. And once it's going back to board, for instance, like silicon photonics, people try to do, and integrated optics, people try to do. Once the EO OE conversion is back onto the board, and I think the rest of the optics demand is just connectivity. And the connectivity becomes the key piece part of optics. Yes. Once people solve the silicon and the electron and the photon together on the same platform on the board.
Yeah, very good. As you say, once that is achieved, then the only real user interface is the patch panel, and right. and making that as intuitive as possible, and also adding some value add, if you will, from a connectivity point of view. What's connected to what, and how do I maintain that over time, and how do I avoid human error? I mean, it's never impossible. It's impossible to completely eliminate, but if you make it more user-friendly, then you're less likely to have mistakes in the field. The holy grail would be that if that was automated, but we've struggled trying to get there, right? And in the meantime, I think an intelligent patch panel is the right objective going forward. And with a modular design, I would imagine that you can eventually build into that as it becomes available, as it becomes cost effective, as you say, and you've got a modular platform. At that point, you could deliver a next generation product. It wouldn't all have to be the same, right? This is, I think, where you were headed before, with a chassis driven, so that your last one doesn't have to be the same as your first one.
Yes. And I understand Verizon is building the one network. We just try to offer the flexibility to meet your agile requirement so that you can do what you want with the innovative solutions we deliver to you.
Yeah, as you say, one network is interesting because by nature, we're not very good at marketing, so it is a kind of what it sounds. You get one network and you support all of your services over the top of it in the engineering side of it. It's truly multi-service over the same network, so you're not building independent silos, and therefore it has to be very versatile and very agile.
Yeah, and also I see when you say multi-service on the same platform, I see a lot of connections.
An awful lot
of you just need to connect them together.
Yeah, an awful lot of connections, as you say. And again, all of those have different attributes. It may be a wireless connection, it may be a business connection, and it may be a residential connection, all on the same patch panel. And this is different requirements, if you will, and that's where the modular functionality really comes into play.
Yeah, and I also see that the requirement goes beyond the central office to the outside plants. Yeah. And we're just trying to also introduce the same technology platform to FDH, for instance, to offer those connections in the outside plant with the easy access and high density.
Yes, very much so. And again, the conditions get worse and worse as you go. Now the poor guy standing in the rain or in the snow in the middle of the night trying to work that same patch panel, and the conditions get even more adverse outside plant.
Yes. So it's quite interesting. I think this industry challenge to us, and we deliver this solution. And this platform solution really has a lot of more applications for us to develop more and more products that will fit various applications on this platform, which is high density, but maintain an easy access.
Yeah, very good. Well, thank you, Simon. It's been great talking to you today.
Thank you very much, Glenn.